Hi, this is a video which will depict a theory in Japanese candlesticks, the stock market. The theory is called landmarks. Now, as part of this theory, this is the first part of the video. This part 1 of this landmarks video will show the function of an AFL. This AFL, we are calling it as visitor. This visitor AFL is supposed to do a particular function. Now I have AMI broker 5.1. Here I have IEOD data, intraday end of the day data for Canara Bank futures. I have 1 minute here and I have 15 minutes here. I can have 5 minutes, 10 minutes, whatever I want. Basically I have 1 minute data here. Now what is required is this AFL is supposed to, when it is applied on any time frame, either on 1 minute or on 5 minutes or on 10 minutes or on 15 minutes or on 1 hour or any time frame, when this AFL is applied, it should do a particular function. What is that function? This theory of landmarks is basically founded on the idea that every fractal, what is a fractal? A fractal among three candles, whenever the middle candle is higher or lower, that is called a fractal. A higher one is called higher fractal or a swing point. Lower one is called lower fractal or a lower swing point. So it is only three candles and not any other number of candles. Wherever you see three candles, the middle candle with the highest or the lowest, whether shadow or body, it's called a fractal. This is a fractal, completely body. This is a fractal, body and shadow, upper fractal. This is also an upper fractal. And this is a lower fractal. Between these three candles, this is the lowest. It's only with body. And this also is a fractal, lower fractal. This body and shadow. Shadow is, this part is called shadow. This is body. This is called shadow. Now, this basic theory, basic belief is that every fractal is cancelled by a opposite fractal, which means, say for example, we take this fractal. This is a lower fractal with a shadow. The idea is this fractal sometime later on will be cancelled by an opposite fractal, something like this. Something like this. Opposite fractal which has shadow, not with the body. The belief is that this fractal can be till here with body or with body and shadow like this, but the later opposite fractal, higher fractal, or if you are taking a high fractal, later lower fractal, whichever opposite ways, the opposite fractal should have a shadow, and if it has a shadow and it comes within the range of this shadow, the previous shadow gets cancelled. That is the idea. So always the first candle's lower shadow or upper shadow, the first candle's fractal will be cancelled by later on one opposite candle's shadow only, not by body. Always it will be cancelled. That is a theory. The theory here needs little bit explanation. Now, what the AFL is supposed to do is, when it is applied, say for example, I'm taking Canara Bank futures 1 minute chart. If I apply a visitor AFL it should do the following things. What is it following things? It should first cancel out all those which have to be cancelled out, and then show me generate through old analysis or new analysis. Old analysis, it should generate, say if I put 1 minute chart, it should generate through parameters, it should generate all the fractals which are not yet cancelled, and it should generate a Excel sheet .csv file, all the fractals which are not cancelled by later candles, which are not cancelled, both top fractals, higher fractals and lower fractals, which are all not cancelled. It should generate and give me through an old analysis, and of course we will give the price range between this price and this price, what all fractals are there which are not cancelled. It should give me till date, right from the inception of the stock till date, of the futures till date. Or if I want a particular between this bar and this bar, or between a particular date, or between this number bar and this number bar, see, as you can see, bar 18 or bar 136, between these bars I want all the fractals which are not cancelled, either upper ones, top fractals or lower fractals. That is what this AFL is supposed to do. It should generate a CSV file with those fractals, whether it's high fractal or low fractal. Now if it is low fractal, the difference between this and this is a fractal, that is, this is low, LF low we call it, and this is OCL, open or close to low. This is the range. And if it is higher fractal, it is called, the tip is called HF high, high fractal high, and OCH, open or close to high. The difference between these two is called higher fractal. The difference between these two are called low fractal. So .csv file should contain 4 columns: HF high, HF OCH, LF low, LF OCL. The 4 columns it should have, containing what are all the fractals which are not cancelled yet between two particular bars, or between two dates, or right from inception till end of this candle. All the quotations. So this is what the AFL should give me. Visitor AFL should give me. Now for this I'll explain to you. See, the output will look like this. When it generates, see, it's a ticker, Canara Bank futures. It gives me time, date and time, sorted. It automatically gives me sorted oldest date to latest date and time. Fractal, this is the fractal color. 0 means red color candle, 1 means green color candle. Whichever fractal candle is remaining, what is the color of that candle? This will show whether it's in 5 minutes or 1 minute or 15 minutes. Now H of high is nothing but, this is H of high, the tip, right? And H of OCH is nothing but H of OCH, open or close to high. This range is called H of high and H of OCH. Same way, LF low, LF OCL. This is a lower fractal range. So it gives me this way. What are all the candles which are not cancelled? As I said, the previous candle should be cancelled by later on opposite candles, opposite side candle fractals. Then only it is considered as cancelled, not same side. This is low, it cannot be cancelled by another lower fractal. It has to be cancelled by a higher fractal candle. whereas this is a higher fractal. Later on it should be cancelled by a lower fractal candle. It cannot be cancelled by a same side candle. Okay, same high candle. It has to be cancelled by opposite side fractal candle. Now, what are the terms of cancellation? This is a 15-minute chart. Visitor is applied. This is a 1-minute chart. Visitor AFL is applied. And the output through, when I give parameters, that is, if I give the parameters like price I have given you between 300 and 260, dots distance, that is just for visual capability. This dot will show you all the fractals. This is a fractal, this is a fractal, this is a fractal, this is a fractal. That's what this AFL is first supposed to show me, all the fractals, and then process only those which are not cancelled. So this dots distance is distance from the candle. It's for visual comfort. Some people want it closer, some people want it further, some people want it much further, based on visual ability. Now, fractal mode, including edges, body and edges, both edges, including shadow. Display arrows. Now, what is this arrow? All fractals. After it is applied, the result on the chart will be that this AFL will show all the non-cancelled, all the remaining ones which are left over after cancellation. Those fractals below that, it will show a green arrow. That's what it means visually, if you want to see on the chart. Okay, less bars, number of bars, like say this is the last bar is 0. You want the AFL to process till say previous bar somewhere. I will give how many number of bars less till where it is supposed to process. Or this parameter also can contain starting bar number, ending bar number. Means this is a 0 is the starting bar number, ending bar number may be some 120. Between these two, I want this AFL to be applied. That also can be part of this AFL, right? And in settings, it has to be put as 1 minute, whichever time frame you want to process, whichever time frame you want to know the candles which are not cancelled, that you have to put the time frame here, say OK, and then press explore. Once you press explore, it will take almost 1.5 2 hours and gives us the result, and the result will look like this, sorted date and time wise, oldest to newest date. This is how it will look. The result is like this. Now, we have explained to you what is a function of visitor AFL, and what is a fractal, what is a higher fractal, what is a lower fractal, and what is the tip of the fractal called in high fractal, what is the tip of the fractal called in low fractal, and the range of these fractals, and how it should be applied on the graph, time frame, whichever we want, and what result it should give. It should give only those candles which are not cancelled, that it should generate. The process also we have given you, automatic, old automatic analysis or new automatic analysis, whatever setting should be in time frame which we want, and parameters between which price to which price you want. Okay, that is what this AFL is supposed to do. Now, what is left is, what are the terms of cancellation? When do you say the first candle is cancelled? This is scenario 1. We will say the first candle is cancelled when, say this also has a shadow, when you say this shadow is actually touching 100, right? and this also is almost touching 100. If you see, yeah, whenever the later shadow, whether it is lower or higher, in this case it is lower, opposite one is lower. Whenever, case one is whenever the later candle's shadow touches the tip of the previous candle's shadow, that is h of high is equal to LF low, it means the previous one gets cancelled. Scenario 1. Scenario 2. If the previous candle's shadow is overlapping this, means you have to take this as a range. From here to here this is a range, from here to here this is a range. LFOCL to LF low, H of high to H of OCH, this is a range. So whenever this range interferes with this range, the previous candle gets cancelled. That is a fundamental idea. So okay, scenario 2, at this price of 99.8 or 7, it gets cancelled, the previous one gets cancelled. Now say the price is 98.5. yes, this shadow is interfering with this range is interfering with this, so previous one gets cancelled. 97, yes, this is interfering with this, the previous one gets cancelled. What about this? 96.5, yes, this is completely interfering with this shadow is completely interfering with this, yes, it gets cancelled. Next scenario, what about this? Yes, part of this range is getting cancelled by, interfering this range, so the previous candle gets cancelled. What about this? Yes, part of this range is overlapping this range, so previous one gets cancelled. Now the question comes, what happens if the candle is like this? When the price LFOCL is equal to HFOCH, what happens then? LFOCL is equal to HFOCH, what happens at that point? Here the fundamental logic is, this range is not interfering with this range of shadow, it is interfering with the body, so the previous candle does not get cancelled, right? That is the idea. Next scenario, what about this? Same, this body is interfering this body, this shadow is not interfering with this shadow, so previous one remains, doesn't get cancelled. What about this? Same, this body is getting interfering with this, not the shadows, so previous one remains, right? Again I'm coming to this, here when these two are equal, this shadow is not interfering this, so this candle remains, it doesn't get cancelled. That is these are the various scenarios when two candles have these kind of shadows opposite to each other. The another scenario could be, there can be sometimes you will face candles like this, that is, this is high fractal with a shadow, but later on candle has only body, LFOCL and LF low both are same, there is no shadow, it means the low and close are same, right? So in this situation what happens? In this situation this candle remains because it is not, this shadow is not interfered by any shadow. See, the basic rule is always same, any previous candle has to be pierced, has to be cancelled only by shadow, not with body, only by shadow of the later candle. So there is no shadow here, so this remains, right? What happens if this is the scenario? If this is the scenario, what if the previous candle has no body and this has got a shadow? This has got body and no shadow, this has got a shadow. In this case, yes, this gets cancelled, because the rule, you remember, is that any candle should be cancelled only by the shadow of a later candle, not body. Shadow is there, and if it just touches this or pierces this or goes much before, this candle gets cancelled. So here is just touching this, and it gets, the previous candle gets cancelled. And say for example, if this is little up, yes, this gets cancelled because shadow is poking it, piercing it. Yes, this gets cancelled. What about when these two are same? Again, same principle. The When this body and this body are touching, when there is no piercing of shadow to the shadow, because this body and this body are touching, that means HFOCH and LF low and LFOCL, all these are same. In such a situation, this candle remains, it doesn't disappear, it doesn't get cancelled. That is the idea. What if it is away from this? Yes, obviously when it is away, it remains, it doesn't get cancelled. Even in your first scenario, we will explain that. Say if this candle is completely away from the top, it is somewhere here, it is nowhere touching, so this remains because the shadow range is not anywhere piercing, touching the tips anywhere, so this remains, it doesn't get cancelled. So these are the various scenarios in which a previous candle gets cancelled, and some scenarios wherein they will remain, previous candle remains. Okay, these are the different types of scenarios which come in when cancelling a previous candle. And once all this AFL calculates all this, takes all these conditions into account, all these scenarios into account, and cancels whatever is remaining, should be given in this .csv file output. It should be, when it is exported, it should give like this. I should be able to export after analysis result is done. I should be able to file, export. When I say export, wherever, to whichever place you want in your desktop or laptop, I should be able to save it as a .csv file. This is what is the basic function of this visitor AFL as part of the part 1 video of landmark theory. Once I get this as a result, that is a visitor AFL applied on any time frame, gives me the remaining fractals, whether high fractal or low fractal, then the next part of landmarks theory can be applied. We will see that in the part 2 of landmarks video. So this, whatever theory I have explained to you, whatever cases I have explained to you, all this are applicable both ways, whether it is this is low fractal to high fractal, sometimes it may be ulta. So for this high fractal, something else will become low fractal. For this low fractal, something else will become high fractal. So other way around also, the other way around in terms of fractals also, these scenarios get applied. This is a video on visitor AFL and its functions and what it should do when applied. Thank you.